Thanks for inviting me. I think that's the most beautiful place I ever presented RAP. So I'm very excited to be here. My name is Ralf Sternberg. I work for Eclipse Source. We are a company based in Karlsruhe, south of Germany. We provide tools and support around Eclipse, things like trainings, long-term support. We also do Eclipse consulting. And we created this project, RAP. RAP stands for the Rich Ajax Platform, around 6 years ago. And I'm with the RAP project since almost the beginning. And since, I think, 2 years or so, I'm co-leading the project, which puts me in the nice position to make all the changes that I ever wanted to make. And the protocol, which is new in RAP and which I will show you in a minute, is one of these things I'm so excited about. As I said, RAP stands for Rich Ajax Platform. That sounds like a web framework, and actually it started as a web framework. It then turned into a single sourcing framework, and currently I'm thinking about it more as a remote application platform. So it's a platform to build applications that run remotely on a client. It's a bit like a remote desktop, if you think about things like Citrix, but it doesn't mirror the desktop, it mirrors widgets. So that's the idea of RAP. I had fun with this iPad application. It's called Paper, and that's why I decided to use that for my slides today. First of all, to set the scope a bit, RAP can also be described as a framework for business applications. I think you can categorize applications by their UI. There are applications that have a great level of complexity, and there are also applications that have a great level of detail. So this application that I'm using here, you see that has all these fancy stuff, and so there's a great level of detail, but there's not much functionality. There are 5 things that you can do with this application, but these are very well designed, very fancy, and that's what goes in this region here. And then you have applications with a big complexity. What I mean with that, I just read that the new Boeing 747 jumbo jet consists of 6 million parts. 6 million parts. Every part has a number, an ID. It has a weight, which adds to the weight of a device, which again adds to the weight of the entire aircraft. It has someone who produces this part, and all these parts have to be managed, right? They have to be ordered and stored and moved and all these things. And if you imagine applications, UI is to manage such a complexity, then you think about these applications that we mostly use RAP for. So these are applications which cannot have such a great level of detail because you just can't do, if you have hundreds of screens, you just cannot put so much effort into everything. So these UIs look like forms. Mostly it's widgets, text widgets, date widgets, and so on. And this is the region where RAP really excels. So imagine you have to write such an application, and one of the first decisions you have to make is, which are your target platforms? Maybe 10 years ago it was simple, the application has to run on Windows, that's it. A couple of years ago, customers demanded web interfaces too. They want at least to have some parts of the application to run in the web browser. And now you had to start write a new UI for your application. If you use Java, like use GWT or JSF or whatever, you have only to rewrite your UI. You can, you can still reuse your business logic. But if these UIs are so large, right? If it's really, and I really have seen applications with zillions of screens, and it takes companies years to write the same thing for the browser. And now customers start demanding mobile clients as well. And so you rewrite your UI with Objective-C, and then with Android, again with Java, with a completely new widget set, and maybe one day Microsoft, what is it called? The Microsoft mobile thing gets more popular. With the RAP, we provide a solution to this problem, which we call single sourcing. So here's basically a sketch how RAP works. You have a server and a client. On the server side, there's a servlet container. RAP runs on every servlet container. And on top of that, we provide a library that's called RWT. That's the RAP Widget toolkit. It has the same, almost the same API as SWT, just a couple of things we cannot implement because they do not work in our way, but mostly it's SWT. So you can use applications that are written against SWT or RCP and just put it on top of RWT on the server. And RWT has also a client part. For the web client, this is written in JavaScript and runs on every browser. It's shipped with the web page, so you do not have to install anything on the browser. And this renders your application on the browser. That was the idea of RAP. And I show you an example how this, or I can show you an example right now. This is a RAP application, right? You have things like widgets like text fields and spinners and combo boxes and buttons and all those stuff. You also have complex widgets like, session timeout. Complex widgets like, there's an interesting one that really shows you some complex data. Do I have that? Oh no, it's not installed here. Damn. Yeah. You know, trees, and we also have drag and drop. So things like that. And now our idea was we have this RWT library which synchronizes widgets between server and client, and it does this using HTTP, of course. The protocol that the client and server exchange information has been a proprietary thing that was JavaScript, and only the RAP team understood what's going on there. And we thought if we can standardize this protocol, we could plug in every client to this. Oops. So we like to think about it just like a power strip where you can plug in any client that understands this protocol. And this protocol is something that we have been creating for 1.5, and it's mostly done, but it will be completely finished in the next RAP version, which is going to be a 2.0. So you can, on the same server, on the same running application, you can plug in a browser, an Android client, and I'm talking about native clients which are written against the Android widget toolkit, and an iOS client which is written in Objective-C but speaks this protocol. So that's the idea. And the protocol is based on JSON, and it's a very simple protocol. The basic idea of this protocol is that we have operations which synchronize the widgets. We can create widgets and we can destroy widgets. So the server says to the client, create a new button and place it on this position. Create a new table, place it here. Set the background color of label 21 to red. Stuff like that. These are set operations. And then you have call operations where you call a function on a remote object. Sometimes you have to do that. For instance, there's in SWT there's a function called display beep, and that's a method call basically, right? So I think I have to hurry up. So the idea is you have one application and different client that connect to this application. Now let me give you a little demo for the mobile client. How do I? This is a little demo application. It's a dashboard for train delays in Germany. There's an open web service that provides information about delayed trains every day. And now you can see where train delay happened on the last days, and you can also see this bar chart. And you see these animations are actually done on the client. We just, these are basically labels or composites which have a background color, and we just set new bounds on these widgets, right? And you can also access the same application from the web browser. It doesn't look so nice here because it isn't created for a web browser, but yeah, that's the idea. I have another small demo. Yeah, this one is interesting. You see, this is actually a tree widget. Now, this the UI is made maybe more for mobile phones than for tablets, and we map the look and feel of a tree widget to something that is common on a mobile device. So, if you expand a tree item, you slide into the next level like this, right? And this demo provides access to a data set with 500,000 emails. That's a public data set from the Enron scandal. And you can browse this email. You see, you cannot, if you have 500,000 data items, you cannot put them on a browser and probably also not on a mobile device in decent time. So this is a virtual tree which loads the items on demand as I scroll or dive into the what's happening here. And okay, let's have a look at the same thing in the browser. It's, what is this called? Virtual tree. And we can also have a look at using Firebug. We can also look at the protocol in action. So if I do something on the client, expand the tree item, then there is a request, and this request is JSON. It's a set of operations, and there are things created like tree items and property set and stuff like that. So that's basically what I wanted to show you. One common question is offline capability. Are we able to write offline clients with this approach? And the short answer is no. RAP Mobile is not offline capable by design, which doesn't have to be a bad thing. If you look at this, if you look at the sketch again, your entire application remains on the server. There's no part of the application and no part of your data going to the client. Only the widgets that are currently being displayed. That means there is no data on the device, and for a lot of applications this is a critical feature. If you think about a tablet application that's used in a hospital, if someone takes away the iPad, there's no data on the device. There's no sensitive data that somebody can steal, you know. But we have a new feature that is called client scripting, and that also lets you do small tasks on the client which are written in JavaScript. So you can bridge some time on the client. You can do some actions on the client. I show this as a last example. This is because this is something really nice, which is part of RAP 1.5. You You see I have a text field where I'm only allowed to enter digits. If I enter some letters, you see there's a slight delay. So this field is validated on the server, and this, the server and client communicate, and you have the network latency. You see this small delay before the text field is going to turn to yellow. So, and now with client scripting, this happens immediately. And you can also do things like turn all the characters into uppercase automatically on the client. So you can do a lot of things with this new client scripting feature, and with really less code. I think my time is mostly up. Well, one interesting thing. Let me go back to the RAP client. Since the entire application is running on the server, oh, now it's not responding anymore. What is this? Here we go. Oh, that's another interesting example of the client scripting. You see, you can draw on the client and... oh, thank you. You see, this is also done by... Oh, what happens? Did this application crash? Okay, you can see it. Maybe this way then. So I can draw on the client, and this, of course, happens exactly on the client without server communication. One last thing that I wanted to show you, but my time is up already, so I have to tell you. Since the entire application is running on the server, of course you can debug your application while the user is accessing it on the mobile device. So you can just set a breakpoint in Eclipse and see what happens. So that's you can use the same tools, and that's one very important point about this idea of single sourcing. It's not just that you can reuse your code, you can also reuse your tools and your knowledge, and that's for a lot of our customers more important than code reuse. Okay, I think that's basically it. I will be around today, and if you have any questions, then please approach me. Thank you very much.